Holy cow, Xiaomi, you know, the Chinese company that makes phones, just made an AI model which might be the fastest in the world. It's called Xiaomi MiMo V2.5 UltraSpeed, and it is truly mind-blowing. In today's video, we'll take a look at this model, see how it works, and I actually managed to get early access to this model, so we'll also test it out with some interesting examples to see how fast it actually is. It's gonna be a lot of fun, so let's dive into it. Before we look under the hood of this model, let's see what massive differences are we actually dealing with here. So on frontier models like GPT 5.5 or Claude 4 Opus, you're often wading through massive reasoning lags, scraping by at roughly 50 or 60 tokens per second. Now that's not bad, but it's kind of slow. But Xiaomi's new MiMo UltraSpeed model is clocking in at over 1,000 tokens per second. And what's even crazier is the fact that this model is also massive in size. It's a 1 trillion parameter mixture of experts model. So you might be thinking, okay, they're probably using some kind of super advanced custom hardware setup for this. Well, actually, not quite. Xiaomi teamed up with their systems partner, TileRT, and they achieved this by using just a single standard server with 8 commodity GPUs. But if that's not the answer, then that begs the question, how do you force a trillion parameter model to spit out text at microsecond speeds on a standard hardware? Well, they came up with something they call extreme model system co-design. They attacked the latency bottleneck from 3 different angles simultaneously. First, they optimized memory bandwidth. Moving a trillion parameters through GPU memory during text generation phase creates massive traffic jams. To fix this, Xiaomi used MXFP4 quantization. But because 4-bit compression can normally make an AI less accurate, they used quantization-aware training, or QAT, and they kept the core routing layers at a higher precision. This alleviated the memory pressure while keeping the model's intelligence nearly identical to the uncompressed version. Second, they ultimately changed the way the model predicts words. So standard speculative decoding works by having a tiny draft model guess a few words ahead, and then the massive main model checks the math. But Xiaomi did something different here with what they call DFlash. Instead of guessing 1 token at a time, it predicts an entire block of hidden tokens all at once in parallel forward pass. And through testing, they discovered that when you use it for coding tasks, the main model actually keeps an average of 6.3 out of every 8 tokens that DFlash guesses. So it essentially lets the model take massive 8 token leaps forward at a time instead of taking baby steps. And third, they used a special engine which solves a really annoying hardware bottleneck. So when you're pushing 1,000 tokens a second, standard GPUs actually can't keep up with the instruction logic. Normally, a GPU launches a math operation, finishes it, clears out the memory, and then waits to launch the next one. And even though these pauses only last microseconds, they completely kill your momentum. To fix that, TileRT built a persistent engine kernel that just sits inside the GPU and never leaves. They used a trick called warp specialization to assign permanent roles to different parts of the hardware. While one section is moving data, another is running the math, and a third is handling communication, all at the exact same time. So the pipeline literally never stops moving. And this is so interesting because I just did a video on diffusion Gemma, which is also super fast, but it tackles the same problem in a very different way. So check out that video if you're interested. And that, my friends, is how Xiaomi gets to 1,000 token per second speeds, allegedly. But now let's actually test it out and see if this promise holds up. So for my first test, I decided to take one of LeetCode's hard questions and run it by the model. And it was blazingly fast. How wild is that? Plus, as we can see here, it peaked at 3,451 tokens per second, which is absolutely insane. Now, there might be a possibility that this LeetCode question was part of the model's training data, so as impressive as this looks, it's probably not a fair comparison. So let's move on to something more sophisticated. Next, I asked it to build a simple UI personal finance dashboard in one single HTML file with no external libraries and nothing too fancy. And in this test, we could now actually see how insanely performant it is. It was averaging about 700 tokens per second for the reasoning part, and about 1000 tokens per second for the output operations, and it took the model just 65 seconds to complete the task, and I think the result is pretty good. Albeit some of the buttons are not working and some of the actions are broken, but the design as a whole is pretty good. I mean, not bad for a 1-minute task. So then I decided to challenge the model to build something even more sophisticated. I prompted it to build a Khan Academy style math explainer webpage showcasing 10 popular math concepts to see how complex of a website can we actually produce here. And this is where things started getting a bit rough. I tried this test twice, and both times after about 2 or 3 minutes, the model just stopped generating and completely froze. So I assumed that with this task, I hit the model's context limit, or maybe Xiaomi has put a rate limiter of some sort. So then I decided to simplify the task a bit by asking it to design a webpage with only 5 mathematical concepts. And this time it finally worked. It managed to finish the task in 75 seconds, and the output is actually quite nice. And the first 3 mathematical concept widgets are actually functional, but everything past that point is broken, non-functional, or empty. So I don't know what exactly happened here. Maybe the model dropped some of its context during the reasoning phase. But nonetheless, I think this is a pretty good result, especially taking into consideration that we were averaging 500 tokens per second during the reasoning phase. And for my last test, I decided to do something a little bit more fun. I just simply prompted this very short sentence to build a Subway Surfer clone using Three.js, and it actually managed to build a fully functional Subway Surfer clone in just 50 seconds. Now that is crazy. I do have to say that although it is functional, as you can see here, it doesn't include any obstacles or coins or anything like that, so it's kind of boring. So I then decided to give it a follow-up prompt to fix these minor issues, and after 2 passes, it managed to successfully add some coins and some obstacles. And honestly, when I was testing it, this was a flawless demo. The functionality was there, everything was working. It was even saving my high score after every round. So this particular demo really surprised me in a very positive way. I'm sure nowadays we can all build Subway Surfer clones with other models as well, but the fact that I could get a working prototype, which is not completely terrible, and which is actually fun to play, and all of that in just 50 seconds with some follow-up prompts, that is pretty impressive. So as we all saw in the tests, the model managed to reach a record speed of more than 3,000 tokens per second. So this is indeed the absolute fastest model I've ever seen. And as far as the outputs go, I mean, yeah, sure, some of them are broken, some of them are half-baked. Surely this is no Claude Opus or GPT 5.5, but I'm sure that Xiaomi's models will definitely keep improving over time. So it's going to be very interesting to see what they come up with in the future. So there you have it, folks. That is Xiaomi MiMo V2.5 UltraSpeed in a nutshell. So what do you think about this model? Are you impressed, disappointed, indifferent? Let us know in the comment section down below. And folks, if you like these types of technical breakdowns, please let me know by smashing that like button underneath the video. And also don't forget to subscribe to our channel. This has been Andres from BetterStack, and I will see you in the next videos.